Yes. Sundus, you also name some
Sulfuric acid.
acids. Sulfuric acid, good.
Citric acid.
Citric acid, good.
Ascorbic acid.
Ascorbic acid, very good.
Sulfuric acid.
Fluoric acid.
So malic acid.
Malic acid, very good.
The nitric acid.
Oxalic.
Which one's on this?
Nitric acid.
Will you please repeat that again?
She says
The
nitric
nitric.
acid.
Nitric acid.
Yeah.
That is also there, very good.
Sir, oxalic acid.
Oxalic acid, very good. And
Acetic
then we have
acid.
acetic acid, very good.
So that's all I remember.
Very good, very good.
The chloric acid is also there.
Chloric acid, you're saying.
Yeah.
Chloric acid is there, right? Then there is one more, tartaric acid. That is found in tamarinds.
Tamarind.
Right now. Okay. So that is the thing over here. And then do tell me one more thing. What are some names of bases? What are some of the examples of bases which we have?
Sir, I'm not sure about bases.
Okay, Sundus.
What actually?
The potassium hydroxide.
Potassium hydroxide. Very good. KOH.
Yeah.
That is an example. And then?
Then something like lithium was there. Lithium hydroxide. I don't know what it was there.
We have example of lime water, calcium hydroxide, right? CaOH whole 2, that is lime water. We have an example of this one also. And then we have
magnesium hydroxide.
Magnesium hydroxide, that is milk of magnesia, very good.
Sir, what about sodium hydroxide?
Sodium hydroxide is the most common base which we have, NaOH. Sodium
hydroxide.
hydroxide.
And the strongest.
It is the strongest also, MgOH whole 2. That is milk of magnesia.
Sir, ammonium hydroxide?
Ammonium hydroxide is also there. That is used as a window cleaner. The solution is used as a window cleaner. So yes, ammonium hydroxide is also there. Very good.
So there's also this one. It is found in baking soda. I think it's called sodium bicarbonate.
Sodium bicarbonate. Very good.
Yes,
so that is NaHCO3. Sodium bicarbonate. Sodium bicarbonate is there. And then you have calcium hydroxide we have written, right? Then we have this potassium hydroxide. You have said that. Ammonium hydroxide, NH4OH. So these are some of the examples of acids and bases. Okay. Okay, you tell me, like this ascorbic acid which you have said, it is found in some fruits also. Yes, ascorbic acid, it is found in some fruits also. Like in citrus fruit, it is found. Like citric acid is found in citrus fruits, and in citrus fruit, ascorbic acid is also found, which is rich in vitamin C. So you have like amla.
Apple council.
Yeah.
Apple.
Apple is also there. In apple also it is found. Okay, like in the sting of the ants, in the ants sting,
Formic
which acid is found? Very good. In the ants sting, formic acid is found. Okay, in curd, which acid is found? The name of the bacteria found in the curd is?
In curd?
In curd also acid is found. Curd is sour in taste, no?
Yes, sir. Yes, sir.
Sundus, you tell me, what is the name of the bacteria found in curd?
Sir, I don't think
Yes. In curd, which acid is found? It starts from L.
So
The name of the
lactic acid.
lactic acid, right? And the bacteria found in the curd is lactobacillus, right?
The what?
The bacteria found
Acid.
in the acid is lactic acid. That is the acid found in it. And the bacteria found in the curd is lactobacillus, right? Okay, now. Then we have vinegar. So in vinegar, which acid is found? One of you have named it here. Acetic acid, right?
Yes, sir, acetic acid.
So that is found in vinegar. Good. Okay. So these are some of the acids. Most of the acids here are actually found in nature. For example, ascorbic acid. This is found in nature.
So malic
Lactic,
acid.
malic acid is also there in nature. Then you have like acetic acid. Tartaric acid is
Malic
found in what?
acid. Tamarind, sir.
In tamarind, it is found. Good. In tamarind, it is found, and it is found in unripe mangoes also.
Yes, sir.
Unripe mangoes.
Sir, oxalic acid.
Oxalic acid. Where is it found?
Sir, I only know one example. It's spinach in palak.
Very good, very good. In palak, it is found. In spinach, it is found. Yeah. Okay. And so these are some of the examples of acids which are found in nature. The one which I'm highlighting in green color. Okay, no. Citric acid is also there, right? Okay. And these are some of the bases which we studied.
Sir, is
Right?
it citric acid or citric acid?
It's citric acid, basically. CITRIC. Citric acid. Okay,
Okay,
now.
sir.
So acid which we studied in the chapter, how do we define an acid? As you guys have mentioned that it will be having a sour taste, right? Acidic substances contains acid in them. Okay, no. By the way, some of the acids does not cause harm to our body. Why is it so?
What
Ma'am,
was
can
the
you repeat
question? I
again?
didn't heard it.
Yes.
Sir, can you repeat the question again?
Some of the acids are not causing harm to our body. Actually, they are good for our body as well.
So like hydrochloric acid.
It is there. Citric acid is there. Found in fruits. Lactic acid is there.
Yes, sir.
Why is it so that they are not causing harm to our body? Because we know the nature of acid is corrosive.
Is not corrosive.
They are actually, yes, on this, they are actually dilute acids. Now they are weaker acids. Right now. That's why they are not causing harm to our body. Right? Okay. So when we talk about an acid, the general thing which you know about an acid is that it will be having a sour taste, right now, and then they are
It turns
like
red, blue litmus to red.
that is there. It turns blue litmus into red. Okay, now, but apart from that, you get to see that in an acid, hydrogen ion is present. Hydrogen ion is found in the acids. Okay, now,
So basically, we're
like when
gonna
you
talk
see
about pH levels, right?
pH, when you talk about pH levels, now thereby pH, when you talk about pH level, it actually detects the hydrogen ion there. If it having too much of hydrogen ion in
Potential
it,
of hydrogen.
potential of hydrogen, right? And that is what pH stands for. Potential of hydrogen, or sometimes also called as potency of hydrogen. So thereby basically you're detecting how much of hydrogen ion is found in the given substance. So when you
Sir,
talk
and
about Mhm.
if it's above 7, then it is an acid. And if it's,
No, if
if
it
it's
is
above
above
7, it is a base.
and below
If it is
7, then
above 7, it is a base, and then below it is base. Acid.
that is true. Then below it is base. We have some common examples like vinegar, lemon, soda, battery acid. These are the household items in which you found acids. And the common items are baking soda, ammonia, then soap, borax. These are the common examples in which you
So
found
talking about
base.
DP acid, there is a chemical in the cell, right?
Mhm.
Uh,
Inside the cell, you have electrolytic chemical.
Sir, so basically it is an acid.
It is an acid.
Okay, sir.
Inside that, you get to see that the medium is actually acidic. Okay, now. So I was thinking, okay, how about we have a small test for this chapter? You guys give some questions, attempts of questions from this chapter. Then we will proceed further in order to check how much do you recall from this chapter. Yeah. By the way, in the batteries, it's not sulfuric acid is found in the battery.
Okay, sir.
Sulfuric acid is found. Okay, now. So you guys would like to revise the chapter first, or just have a small test for the chapter? Then we'll proceed further, huh?
So can we like revise for 5 minutes or like 10
Yeah,
minutes?
sir. Revise for 10 minutes.
Okay, okay. So let's revise the chapter quickly first. Okay. So talking about an acid is substances that are having sour taste and they are corrosive in nature. They will be turning blue litmus paper to red. So as you have taken a blue litmus paper, and when you dip it in acid, you get to see it is turning into red color. Getting it? Okay. So that is another thing about it. So these substances are chemically acidic in nature. Common examples are as follows. Now further acids will be of two types. Acids will be of two types. So one that is occurring in nature, one that is made in the laboratory. So acids
Sir,
on the basis of origin. Yeah, Chakri, I'm listening.
so litmus is also a natural indicator, right?
Litmus is also actually a natural indicator. Okay, now basically lichens that you see now, lichens.
Yes, sir.
It is made from that. So it is extracted from the plants and then it is dried. Okay, and then converted into that paper form. So that
Okay,
is
sir.
what it is. Paper actually is. So it is obtained from lichens, but you can't be using it in direct form. No, like in that raw form, it is not in a usable state. Okay. So see, on the basis of origin, where the acids is coming from, it is of two types. One that is the natural acids, which we also call as organic acids. All right, now. And then you have the man-made acids, which are also called as synthetic acids. All right, now, which are made in the laboratory. So common examples of natural acids are what? You have citric acid, you have formic acid, acetic acid, ascorbic acid, oxalic acid, lactic acid, or and then tartaric acid also. All these are examples of naturally occurring acids. All right, now. So for example, let's note down some examples like tartaric acid, acetic acid,
Oxalic acid.
oxalic acid. So just to name few, these are some of the organic acids. And then you have some man-made acids also, right? Now, like sulfuric acid. Sulfuric acids are there, nitric acids are there. So these are some of the examples of it. Okay, no? So hope you understood this thing. Now, by the way, this nitric acid, now it is both synthetic and it is actually naturally occurring also. How is it so? Because when uh, acid rain happens now, so acid rain consists of sulfuric acid and nitric acid both. But we don't fully say it to be organic acid, natural acid. Why is it so? Because
It is corrosive
oxides of
nature.
it is corrosive in nature. That is true. If, in fact, organic acids are also corrosive, but not that much corrosive. So corrosive is not the base for distinguishing between the two. Both are acids, but the strength of corrosiveness is less and more in the two. So I was saying that in acid rain, you get to see that oxides of nitrogen and sulfur are there in the atmosphere. Due to the smokes, due to the pollutants arising from the chimneys, NO2, NO3, these are the oxides of nitrogen, namely the nitrate and nitrite. All right. And then you have sulfur
Okay.
dioxide also. So when these will be combining with the rainfall or rainwater, thereby they form nitric acid and
There is
sulfuric acid.
also there's also another one, sir. Sir, I think it's carbonic acid. I'm not sure, but
No,
there
usually
are
carbonic
three.
acid isn't there. Normally, oxides of nitrate and sulfur dioxide is seen there in the atmosphere normally. This is found in abundance in the rainwater. Okay, now some amount of other acids could also be there, right? Because it's not like only the oxides of nitrogen and sulfur is there in the atmosphere. Certain other oxides are also there, which when combined with rainwater forms acid. Okay, now. So that is the thing which I am trying to say, that on the basis of origin, there are two type of acids, organic and then the synthetic. Now on the basis of strength, you will again have two type of acids, weak acids and strong acid. Okay, now. So weak acids are also called as dilute acids, and the strong acids are also called as concentrated acids. Getting it now? Why is it that they are called as so? Why it is called as dilute? Why it is called as strong? Because the fact is that one is less corrosive in nature, one is more corrosive in nature. Right now, on the pH scale, you will get to see that this is 7. Let's say this is 0. This is 14. So in the pH scale, you get to see that the dilute acids will be having a pH somewhere between 5, 6, or close to 7, 4, 5, 6. Getting it now, guys? While you will find that the strong acids will be having a pH of 1, 2, or 3. Getting it, Sundus and Chakrika?
So,
Okay, so that is the difference between the two. Another important thing we get to know that it will consist of less hydrogen ions in it. Less hydrogen ions in it. While this will consist of more hydrogen ions in it. Then you can say this is less corrosive.
sir,
Hmm.
will you be like asking questions like in which color this particular indicator turns into if a base or an acid is added?
Normally, I would be asking whether it will be red or whether it will be blue. But when you look at the pH scale, now there are some sub colors in it also. But that I won't be asking. Okay, now, because usually in that much of
Oh,
depth, questions are not asked. Okay.
okay, sir.
So is the difference between the two clear? Is the two classification of acids clear to both of you? Yes, Sandus, is it
Yes,
clear?
sir.
Okay, so that was a general
Yes,
thing,
sir.
by the way. Talking about basic substances. So basic substances, what do we know about that? Before moving that, let's revise these general things also. Like always add acid to water, not water to acids. Because when you will be adding water to acids, that will be an exothermic reaction. So much amount of heat will be released.
And so normally during neutralization, heat is common, right?
That is a
Yes, sir.
different
I
thing.
didn't hear. Can you repeat again?
I just said, no, Sandus. Normally, acid is added to water if you are required to make a concentrated acid weak. If you are required to make concentrated acid weak, so normally drop by drop you will be adding acid into water, and then using a stirrer you will be stirring it continuously. That's how you dilute an acid. While you won't be adding acid directly to the water, because that will be an exothermic reaction. Exothermic reaction is what? Exo means something that is released out. Thermic refers to heat. Getting it now? Exo means heat. So heat will be liberated out in very good amount here. That's why we don't do it. Yeah, Chakrika, you were saying something.
Yes, sir. I was asking that. I mean, I was saying that even when we add uh, acid to the water, still heat is evolved, right? Even a little bit.
Even then also it will be evolve even a little bit. When you touch this glass beaker,
And
no, then you will feel it becomes warm.
so we also can't add water to all the acids, right? I
We
mean, we
can't
can't
add
also acids to all the water, right?
we can't add acids to all the water.
I mean, we can't add all the like any type of acid to water, right?
No, pretty much we can add all the acids to water. Okay, now in a well organized manner, okay, now you can drop by drop add, no matter how concentrated the acid is, it can be added to the water and thereby it can be diluted. All right now.
Okay, so
Mhm. And when you are doing this thing now, when you're diluting acids, you need to uh, wear the safety glasses and gloves and then shoes. All right now. So that is the thing about it. And bases, as you know, okay, bases are soapy in and touch. They will be turning red litmus paper into blue. All right now. Okay. So the properties of bases are as follows. They are the chemical substances that has a bitter taste. Bases will be found in different type of substances at our home. For example, it will be found in bleach. At our home, it is found in bleach. It is found in the window cleaner. It is found in the washing powder. And the most common, that is
Baking soda.
baking soda is
baking
also
soda.
there. Soap and then baking soda is also there. Correct it now. So these are the common products at our home in which it is found. Now, some of the bases are actually dissolvable in water. Some of the bases will dissolve in water, while not all the bases will be dissolving it.
Sir, and
So,
the bases which are dissolved in water are called alkalis, right?
alkaline, or alkalis are
Yeah,
also, but
alkaline.
alkaline right now. So, we see that some bases are alkaline. That means dissolves in water. So, what we say here now, we say that all alkaline are bases, but not all bases are alkaline. Let me repeat. All alkaline are bases, but not all bases are alkaline. Getting it what I'm trying to say?
Yes.
All alkaline are bases, but not all the bases are alkaline. Getting it now, Chakrika and Sandus? Bases
Yes, sir.
are. So that is the thing. Some other examples like calcium hydroxide is also there. So these are some of the examples, and they will be converting red litmus paper to which color? Pink. They will be converting it into blue color, right?
Yes.
Okay. Now, before we move on further now, first of all, you tell me, like, if you were to test the litmus paper, for example, on tap water, what will happen? Will the color change to blue or red?
So,
Sir, can you
and it
repeat
will
the
not
question
change to
again?
any color.
Hmm, very good. Blue, red, or neutral. So thereby it
Neutral.
will be neutral. Good. What if you were to have a soap solution? Hmm. So will it be blue
So,
or red? By the way, we have not taken this paper right now. Let me make one more boxes over here. So let's take say that you have taken red litmus paper, and then you have taken a blue litmus paper. Blue litmus paper. And here you have to just tell me the color will change to what. Soap solution we have taken. So this will change which paper to which color.
The blue.
Which one? Red litmus paper to blue or blue litmus paper to blue? Obviously, red litmus
Red
to blue.
litmus.
Okay. To blue, good. What if you were to take shampoo solution? Shampoo is what?
The red litmus. I think so. Red litmus for me.
No.
No, sir. I think it's blue litmus. It'll turn into blue litmus.
So it converts blue litmus paper into red. So thereby, what we get to know about shampoo, is it acidic? Isn't it acidic in nature? The shampoo is actually acidic in nature. This is basic in nature. Many a time people confuse that shampoo is basic in nature, but it isn't.
Sir,
Mhm.
wait,
Yeah, Chakri, I'm listening.
which acid is present in shampoo? Yes, sir. Which acid is present in shampoo?
That is not important. That isn't important. Like it's a mixture of
How do
different.
we
Must be.
exactly know that it's a acid then?
We basically conclude that it is an acid because it is changing blue litmus paper into red. Okay, so thereby, with the simple observation, we can conclude that this is an acid. Okay, now.
Yes, sir.
Common salt. You have taken common salt solution. So that will change to which color, or will it not change?
Sir, it will
So
not
it will
change.
not change.
It will be not changing. Thereby, it will be neutral. Or what about lime water?
Sir, it turns blue litmus to red.
It turns blue litmus to
Yeah.
Red.
if it is changing blue litmus paper into red, thereby lime water means then it is acidic now. But lime water is an example of base now. So thereby it will be
So
changing red
lime
litmus
water.
paper.
So lime water
Because
is
actually
acidic.
I was confused because lime water is also like having a acid in it.
No, lime
I
water is, look, now you're confusing it with lemon water. Lemon water and lime water, those are two different things here. See, calcium hydroxide is called as lime water. Getting it, guys? Understand this thing. Lime water is this calcium hydroxide. I think you guys got it confused with lemon water. Lemon water is acidic in nature. Getting it? What I'm trying to say.
yes, okay.
Mhm. So lime water will be changing red litmus paper to blue. So thereby it is acid basic in nature. Hope it is clear. Okay. What about vinegar? Yes, vinegar will do
Sir,
what?
The red to blue.
it's a base.
No. Be careful.
So it's a base, right?
Vinegar is a base. No. Acid is found in vinegar.
Oh yes, sir.
Guys, acetic acid is found in vinegar. Okay, now.
Yes, sir. Yes, sir.
We are required to join room number 1, I think. Just give me a moment. Okay, guys, we are required to join room number 1. All right now. So join this room, everyone. Okay.